Here for the post-incident review on PIR 2026-1847 SEV1 with full production impact. Let's walk through what actually happened. The service is an AI-powered operations platform with 3 production clusters. The timeline: AI ops tooling deployed to production in January. No one looked at the build for 10 months because it was buried inside of a larger platform line item, as you do. By the time someone actually graphed the cost in isolation, it looked like this. The curve was already approaching vertical and the spend had hit 50 million. The CFO scheduled a meeting with engineering. Engineering did not enjoy that meeting. The blast radius was effectively all production environments. The platform was making automated scaling decisions. Every decision was technically correct, but every decision was also expensive. Nobody defined what too expensive meant, so why would the AI have? The root cause, if you believe in such things, is that the transition plan from POC to production did not include a line item for economics. The AI did exactly what it was told. It just wasn't told to care about the bill. Nobody was. Now, this incident hasn't happened yet, but I've been staring at cloud bills long enough to recognize the precursors, and I'm seeing directionally all of them now. The only question is whether this happens to you or to someone whose failure you get to learn from for free. That's what the talk is. Your AI doesn't know what things cost. And the gap between working and affordable is where careers go to have difficult conversations with finance. So let's talk about why that matters, what it looks like when it goes wrong, and maybe even what you can do about it before it does. I am Corey Quinn. I do a bunch of things like helping companies figure out what they're spending on AWS and friends, along with why. I also published Last Week in AWS. And I've watched the same pattern play out with cloud migrations, containers, serverless, new technology, excitement, proof of concept. And then someone says, ship it. And then the economics hit like a freight train that was on the schedule the whole time. And I'm watching it start again. Now, everyone watching this presumably is running proofs of concept right now, which is good. That is what you should be doing. You don't optimize what you haven't validated first. And I'm not here to yell at you about your POC spending. Yelling at someone about the cost of a first date kind of misses the entire point, because the point of the first date is to figure out if there's going to be a second date. But here's what I'm seeing is that nobody picks the cheap, crappy model for the POC. Nobody's using Amazon Nova because it sucks. Nobody's reaching for the budget option because why would you? It's a POC. You want it to work. Does this thing even work? Because cost doesn't matter yet. But just like the size of the instance you pick in dev, the model you pick for the POC is very often the model that ships to production because nobody goes back to check. The POC cost is and remains a rounding error. And you don't have to care. Again, you shouldn't, because the danger is the transition. POCs that succeed get promoted to production with the POC's architecture, the proof of concepts model selection, and absolutely no cost model whatsoever, because nobody builds that cost model early on. That's not what it's for. No one builds it during the transition either, because by then someone said ship it and the conversations moved on to reliability and scaling. Cost is tomorrow's problem. It's always tomorrow's problem right up until it's today's emergency. Now, I haven't seen the AI version of this bill yet, but I've seen every precursor, and the pattern isn't subtle. It's also not new. Just spin up another instance was the answer to every scaling problem for a decade. 10 cents an hour, who cares? Then the bill arrived because just to spin up another one of these at scale means cross-AZ data transfer, NAT Gateway charges, CloudWatch ingestion fees, EBS volumes that nobody remembered to delete, let alone their snapshots. And that's how companies that called themselves mostly serverless ended up with a $47,000 a month NAT Gateway line item on their bill. AI is following the same pattern with worse unit economics, and this time the marginal cost isn't 10 cents an hour, it depends on how much your model talks to itself, which is not a thing that finance or the rest of us really know how to forecast. Now, every story needs a villain, and the villain in this story is the same villain as it is in every story, which is, of course, Kubernetes, a miserable software invented by presumably miserable people to inflict their misery on the rest of us. So here we go. Piping Kubernetes state through AI is the most efficient way to set tokens on fire yet invented. Pods, nodes, services, ingress rules, config maps, secrets, events, logs, AI tools that promise to help you manage all of that need to ingest all of that. Every context window is a billing event. Your 12 node staging cluster is a toy and it costs toy money. No one notices. But production is 1,200 nodes, and the relationship between 12 and 1,200 is not linear when you're paying per token. It doesn't even approach linear. It's the kind of nonlinear that gets its own line item and its own meaning. I know this because I run a home Kubernetes cluster in the sewing room, as you do. A few nodes, nothing particularly fancy. It was emitting millions of events a day at one point. Millions? Why? I genuinely do not know. Only God knows, and she is not answering my tickets. This is a toy cluster, a hobby, admittedly a badly run one, but still. If my home cluster is doing that, what do you think your production environment's doing? And if you pipe all of that through an AI tool that charges per token, you're not paying for insight. You're paying for the privilege of ingesting your own noise. Let me walk you through what happens when your AI ops tool investigates a single pod crash. Step one, pull the pod spec. Step two, pull the events. Step three, pull the logs. Which logs? All the logs. Step four, pull the node status. Step five, pull the service mesh configuration. Oh, what's this? Do you have multiple service mesh? Doesn't matter. Pull them all. Step six, pull the last 30 minutes of metrics for everything that touched that pod, which is kind of a lot, for a single diagnosis. One pod, one crash, somewhere between 50 and 200,000 tokens of context, depending on how chatty your cluster is. Now multiply it, because you had 47 pod crashes today. Each one triggered the same investigation. Each investigation consumed roughly the same context window, and your AI tool didn't cache any of it because each crash looks different enough to require fresh context. So 47 pod crashes, 47 full context investigations, and that's a quiet Tuesday. The meter's running the entire time. Every token in, every token out is a billing event, but unlike your compute instances, there's no metric that's ticking up on your dashboard usually. There's no alert threshold that is slowly turning red. The first time most teams discover what their AI tooling actually costs is the first invoice. By then, the architecture's set, the tools in production, and the conversation is no longer, should we do this? It's, how do we pay for this? Let's do the napkin math on it. We'll keep it simple. A large context API call, 200,000 tokens in, a few thousand out, is going to cost somewhere between $1 and $5, depending upon the model. $5 for the good models, and closer to $1 for the shitty Amazon Nova model. Fine, that's one call, one diagnosis. Your production cluster generates how many events per day that are triggering your AI tool? If it's 1,000, that is $1,000 to $5,000 a day. If it's 10,000, congratulations, your AI tool now very likely costs more than the infrastructure that it's helping you monitor. And it doesn't scale linearly. This is the part that makes the CFOs stop smiling fast, assuming you're lucky enough one of those CFOs that knows how to smile in the first place. The bigger context windows cost more per token. More complex problems require more back and forth. Retry logic on failures doubles the cost. Providers charge different rates for input versus output tokens. The model thinking about your problem is more expensive than the model reading your problem. By the time you hit production scale on this, the cost per diagnosis has multiplied, not just the number of diagnoses. It becomes fractally expensive. And staging lied to you about all of this because your staging environment has 12 nodes. Production has 1,200, remember? Staging has synthetic workloads that fail in predictable, well-documented ways. Production has real workloads that are messier, noisier, and generate 10 times the events. The cost you measured in staging is not the cost you'll pay in production. It's not even the same order of magnitude. You measured the water temperature in the kiddie pool and declared the ocean safe for swimming. Don't do that. And here's the thing that absolutely nobody in the space wants to hear. Cost optimization and reliability engineering are the same discipline. Just like cost and architecture are the same thing. You've put them in separate teams, separate budgets, separate meetings, separate OKRs. They are the same meeting. You've just put them on different calendar invites. Every cost decision is a reliability decision. Every reliability decision has a cost. If you don't believe me, try cutting your monitoring or observability, which means hipster monitoring, budget, and then see what happens to your uptime. Auto scaling saves you money until it doesn't scale fast enough. Right sizing saves money until the workload spikes. Reserved capacity is cheaper until you don't need it. Spot instances save 70% until they get reclaimed during your busiest hour. Every cost optimization is a reliability bet. The person making the cost decision is usually not the person who gets paged at 3 a.m. when the bet goes wrong. Those two people should probably talk at some point. They usually meet for the first time in the incident review. AI tooling, surprise, makes this worse. Traditional infrastructure means you can scale the servers, you pay for the servers, it's simple. It's expensive, but it's simple. AI tooling means that the tool costs money. The tool is also sometimes wrong. And when the tool is wrong, it somehow costs more money. That is three problems that used to be one problem. Your AI ops tool is an expense that generates expenses and occasionally generates incidents that generate expenses too. It's costs all the way down, and you tested the brakes on a bicycle. Now you're driving a bus on a highway at night, and the brakes are probabilistic. The accuracy that you measured in test doesn't predict the accuracy you're going to get in production because the data is different, the scale is different, the failure modes are, surprise, different. Meanwhile, you're paying for both environments, and the cost of not running the AI in production is the human toil it was supposed to replace. So you're paying either way, you're just choosing which bill you'd prefer. Every tool in the expo hall today at every conference has this cost property. Every one of them. The demo looked great. 12 nodes, synthetic workload, pre-selected scenarios, diagnosis was fast, cost was trivial. That's staging. There's a reason that things work in theory but not in production. That's why my staging environment is called theory. No one demos at production scale. Who could afford it? Nobody puts the API bill on the demo screen. And that's not a criticism, it's trade show physics. But it means that the cost number that you saw on the demo is not the cost number you're going to see in production. When you talk to the vendors, and you should because they're building useful things, ask the question that they're hoping you won't. What does this cost per event at our production scale? Not staging, not demo, the environment with the 1,200 nodes and a million events a day. And watch the answer. Because if it starts with, it depends, you're having the right conversation. If it starts with, let me get back to you, you already have your answer. Now, some of these tools are per seat or flat rate subscriptions, in which case, great. The token cost isn't your problem, it's the vendor's problem, which sounds great until you think about it for 30 seconds. Because if your vendor is losing money on every API call that you make, they're either going to raise your price or degrade your product, probably both. If they don't do either, they go out of business. You haven't eliminated the cost, you just moved it somewhere you can't see it, and you've given someone else the incentive to make it your problem later when you least expect it. And then there's the ownership question. When it's everyone's responsibility, it's nobody's responsibility. Security has figured this out the hard way. DevOps mostly has figured this out. FinOps is pretending this hasn't happened yet. Engineering is making cost decisions every day and doesn't recognize them as cost decisions. The model selection is a cost decision. The context window size is a cost decision. The retry logic, surprise, cost decision. Batch size, caching strategy, the fallback behavior. No one has called them cost decisions. No one has put them in the budget. They're pull requests. Meanwhile, finance makes technical decisions it doesn't recognize as being technical decisions. Cut the AI budget by 30%. Okay, which 30%? The part that pages you at 3 in the morning or the part that doesn't? Do you know? Does anyone in this meeting know? The AI tool's sitting in the middle, making both kinds of decisions and reporting to neither team. It's the most expensive employee in the company, and it doesn't even have a manager. Now, the grown up move here is not about panicking about your POC budget. If that's the takeaway you have here, then I've failed. Because keep experimenting. POCs are cheap and they should be. But the grown up move is having a plan for the moment someone says, ship it, not after, not during the incident review, before. Now, and here's the good news, and I mean this sincerely, that you are the right people to solve this problem. You presumably already do incident response. You already set SLOs. You already run error budgets and on-call rotations and blameless postmortems that are somehow Steve's fault. You have the entire discipline. You've just never really pointed it at cost in this way. It's not a new skill. It's an existing skill you already got with a new input because the playbook's the same. The meeting cadence is the same. The alerting infrastructure is the same. You just need to add a dollar sign to the dashboard, unlike some vendors who will add many dollar signs to a dashboard, which is neither here nor there. So, first, know what model you're running. Schedule the model bake-off before you ship, not after the bill arrives. Block out 2 days for it as a rule of thumb here. Test your actual workload against 3 or 4 models. Measure the quality and the cost, because good enough at a tenth the price is a real outcome that nobody discovers when the only model they've ever tested is the latest Opus model. Good enough requires knowing what enough means. That's not really an engineering question. That is a business decision that engineering made without realizing it. And the window for making it closes the moment someone says ship it, because at that point, changing models to a less expensive one means a degradation in service that people have come to expect. So here's how to actually do it. Take your 10 most common AI operations, the real workloads, not synthetic benchmarks. Run them against 3 or 4 models at different price tiers and score the quality on a simple scale. Plot the quality against the cost. And you'll find that for most workloads, in most situations, the model that costs 80% less scores a 4 instead of a 5. And a 4 is fine. 4 is good enough. But nobody discovers that when they skip the bake-off stage and they ship whatever the hell happened to work first. Second, if your AI makes a bad scaling call, it's an incident. Treat it like one. SLOs for your AI tooling, error budgets for your AI tooling, incident response for when your AI does something expensive and wrong simultaneously. You already know how to do reliability engineering. You do it for everything else in your stack, or at least you claim to. The AI tool's not special. It's infrastructure that's probabilistic. If you wouldn't let a junior engineer make unreviewed production changes, maybe you should be asking why you're letting a model do it. Think of it as intelligence of 18 and a wisdom of 3 for my D&D friends. I had a logic bug a little while ago in one of my apps. I know. Imagine that. It started hammering the Anthropic API, $50 an hour. The usual spend for that account was $12 a month. So I caught it at $50 because Anthropic bills directly and in near real time, and I could see that spend in real time. Now, if I'd been running that same workload through Amazon Bedrock, I wouldn't have gotten that alert for days, if not weeks. AWS billing, in case you weren't aware, is not designed for real-time cost feedback. By the time Cost Explorer caught up, there's a very real chance that that $50 would have been $50,000. The difference between a $50 lesson and a $50,000 incident is not better engineering, it is faster billing. That's me, someone who stares at cloud bills for a living. I had real-time billing and I still almost missed it. What's your cost feedback loop? How long between something went wrong and someone sees the bill? Because if the answer is it's the monthly invoice, you're going to have a very bad month. So here's what the cost SLO looks like in practice. Set a daily spend threshold per AI workload. Alert at 80, page at 120. Put it in the same channel as your latency SLOs, because the person who needs to see the cost spike is the same person who needs to see the latency spike, believe it or not. Now, how do you actually measure it? It's not always as simple as adding one span attribute, because you need token counts, input and output priced differently. You need to know which model handled the request. You need to account for retries, downstream chains, tool use costs that spawn more calls on top of that. It is a real instrumentation project. But if you already instrument for latency and error rates, so this is the same discipline you're applying to a new dimension. Start with total tokens per request, because that alone is gonna surprise you. Third, the industry is generating expensive AI failure stories at an unprecedented rate. Read them. Most of them aren't even trying to sell you something. The companies that are 3 months ahead of you on the adoption curve are generating the lessons that you're going to need before you need them. Postmortems, case studies, blog posts that very carefully don't mention the dollar amount but describe the blast radius in enough detail that you can estimate it yourself. The information is free, the mistakes are not. I'm exaggerating. The information is usually free. Some of it requires an NDA. Pay attention to quiet incidents, the dramatic failures, hallucination, prompt injection, data leakage. Those get the headlines. The ones that apply to you are the quiet ones. Cost overrun, billing surprise, budget exhaustion, worked as designed just expensively. Those don't make the news. They make the meeting with finance. Start a reading habit. One AI incident report a week. The AI incident database exists. Bookmark it. Fourth, get engineering and finance in the same room before you need them there. The model selection's a business decision wearing an engineering costume. Nova exists. It's crappy, sure, but it's cheaper. It might be good enough, but good enough is a business call, not my call. It depends on margins, customer expectations, competitive positioning. Engineering does not have that context. Finance doesn't have the technical context to know which models to compare. If these two teams meet for the first time during the cost crisis, you've already lost. You're going to cut the wrong budget, optimize the wrong workload, and have the argument 6 months too late. The meeting is easier to schedule when nobody's angry yet. The teams that I've seen get this right all did the same thing. Nothing exotic. They just had the conversation before someone was angry. Engineering showed finance what the model options actually were and what they cost. Finance told engineering what the margins could support. They agreed on thresholds before there was a threshold to argue about. They set up cost alerts the same way they set up latency alerts because they're the same kind of alert, and they continued iterating on this. None of this required new tools. None of this required a new team. It required one meeting that nobody wanted to schedule, and everyone was glad that they had. You're going to finish watching this talk and go back to your actual job, because that's how conference talks work. 72 hours of good intentions followed by 6 months of nothing. But here's how to make next Monday different. 3 meetings. That's all it is. Meeting 1, your team, 15 minutes. Do we know what our AI tooling costs a day? If not, who can find out by Wednesday? Meeting 2, your finance partner, 30 minutes. Here's what we're spending on our AI tooling. Here's what we think production will cost. Here's the delta. Are you comfortable with that number? Meeting 3, whatever vendor you've got there, 15 minutes. What does this cost at our production scale? Show me the math, not the marketing. And one technical change. Start instrumenting the cost of your AI calls. Not the full picture, that's a project, not a Monday morning task. But start with the basics. Log the token count and the model name on every AI call. Input tokens, output tokens, which model? That is not a complete cost model. It doesn't capture retries or downstream chains or difference between cache and uncached context, but it gives you a number where today you likely have nothing. And the first time you see that number, you will have opinions about it. They're probably going to be strong. That's the Monday morning agenda. 3 meetings and 1 instrumentation task, because everything else is follow-up. Remember the preventable incident from the beginning of this talk? The model selection already happened. No one picked Nova. The POC architecture is already set. The transition plan doesn't exist. And everything that leads to this upcoming incident is already in motion. The only thing that hasn't happened yet is the bill. Your AI does not know what things cost. That's fine. It's not supposed to, because that's your job. It's not just engineering's job. It's not just finance's job, but both in the same room before the bill hits. And the window closes the moment someone says, ship it. You still have time, but not because you have months, just because you haven't pressed the button yet. I'm Corey Quinn. Thank you for tolerating my ridiculous nonsense.